Hello, everyone. Welcome to another community call with Memgraph. My name is Marco. I'm the CEO of Memgraph, and we've got a very interesting topic today, which is going to talk about how to get the best answers from your data sets with Graph. And one of the things that we definitely want to talk about and want to share is the architectural aspects of it. So basically the architecture setup that traverses various domains, but basically persists and allows us to get those answers out. So with me today, I've got Max Lady from Pinboard Consulting, who will share with us basically everything that he has learned over the last year and a half, 2 years, of solving these problems with customers and building the systems and apps and the kind of software for them. So without further ado, I'll leave it to Max to take it forward.
Awesome. Thanks so much. Let me share screen and then kick off properly. Okay, yeah, Marco, let me know when the screen's properly visible.
Yeah, I can see it.
Fantastic. So yeah, thanks for the introduction. I think the reason we decided to do this is because so many of our clients, either existing clients, potential new clients, etc., are moving beyond sort of POCs into productionization. Talking to people like Memgraph, talking to people like Pinboard Consulting, and finding out that lots of other people in their industries have already kind of done similar things. And I think there's a real interest in finding out how have other people solved these problems? How have other people encountered the same challenges? Have other people done, etc.? So I thought between myself and Marco, it'd be really good to talk about some of the common problems, common solutions, common domains. And this is kind of really the point, right? Unique domains, common solutions. So we'll go through this, but by way of introduction, for those that don't know kind of me or Pinboard Consulting, we're a dedicated graphs plus AI consultancy. We started off purely, graph and graph only, but then as the LLM world kind of woke up to how useful graph is, particularly after the Microsoft GraphRAG paper, which kind of kicked off a bunch of interest, but also context and graph memory and graph neural networks, etc. Pinboard has followed where our clients have gone, right? Our clients have gone from being just interested in graph to being very interested in graph plus AI, and Pinboard's followed them on that journey and really helped them. And so what I'm going to go through today is for specific use cases. Unfortunately, I'm afraid, without naming brands or logos necessarily, but real use cases, real scenarios, real problems, real solutions. All of these things are either in production or about to go into production. So these are not POCs anymore. We've been helping companies now, as Marco says, for a year and a half, 2 years on real things. We're kind of past the POC phase and very much into, live or nearly live. What I would say though is I'd love this to be interactive. I can just sit here and talk, but I'd prefer it if people could raise hands, ask questions, interrupt. I guarantee if there's something you want to ask, then the other people on the call will probably have the same questions. So please do raise hand. Marco, if I don't spot that or I don't respond, or if you see maybe a question in the Q&A in the text, just stop me and ask me. This will be a lot more informative if it's interactive. So with that, the first one, again, unfortunately, I can't give logos for these. In the cases, I think most people very much kind of feel that their LLM solutions, their multi-agent solutions, their graph solutions are differentiators. They are part of their competitive advantage. So although they suspect their competitors are probably doing similar things, they don't really want all the details of who they are and what they're doing out there in the big wide world. So unfortunately, I tend to be quite restrictive in terms of logos, but we'll work around that. I'll try and give you a flavor of the clients and the use cases as far as I can. So this one was a giant law firm, as I mentioned. The use case was for a legal assistant chatbot, and the key scenario really was, tell me everything I need to know. That's the absolute top line summary. If you're a senior lawyer, maybe you're a partner or assistant partner, you've just signed a deal for instance, a new hydroelectric dam in Malawi. You want to know everything you need to know. What they're trying to do here really is accelerate the gathering, accelerate what might have been a 2-day process, a 2-week process, and get it into a 2-minute process, right? Something where you can just go to the chatbot, type in something into a prompt, and then the solution would be able to go through a truly vast corpus of unstructured data. So of all the clients that we dealt with in terms of unstructured data, this was far and away the largest, right? Laws published by the government, regulations published by the government, judgments published by individual courts, cases with case notes, perhaps in newspaper articles, in court reporting, in judgments, contracts, internal documentation. So what previous contracts have we had? Well, we previously had a contract for doing a nuclear power station in, maybe somewhere else. So anything which could be relevant, prioritized, give it to the head lawyer, so they could really accelerate their production, accelerate their productivity, get their hands on what they need when they need it as quickly as possible. And within contracts, of course, service agreements, previous deals, addendums, subcontracts, contracts for sub-subcontracts with clauses. And so, yeah, it was quite an astonishing array of unstructured data. And Graph plus LLMs just worked incredibly well. They had tried to do it purely with vector, struggled because of the interdependency problem. This isn't a vector versus graph kind of discussion. I think most of the world now knows that, graph's the answer, unless you're doing incredibly simple things. Graph is just going to give you a better result. And this company had realized that, brought us in to assist. Luckily, we were able to help them quite a bit. But yeah, any questions on this one before we move on to the next use case? Give it a second. Okay. The next one, and these are almost chronological, not quite, but almost, was manufacturing supply chain. So this was for a global giant manufacturer looking at their supply chain, and their particular problem that they were trying to solve was cost modeling and attribution. So the key scenario in this case would be a question like, what would be the impact to margin? So already an interesting question on finished goods. Okay, well, margin's normally done at finished good level, so not that complicated. But if the cost model is for ingredient, for this input ingredient changed for this component of the cost. So if you try and unpick that in a tabular kind of world, you're just going to die. You're going to die by external joins. You're going to have to join so many tables, denormalize your data. But in a graphy sense, you can build a graph solution that's incredibly powerful and can answer these exact type of questions. Because if you think about the core of what this question is asking, it's really the bill of materials. So a bill of materials is a DAG, for those of you who know graph terminology, so a directed acyclic graph. SAP is a global giant that is being built around an incredibly complex bill of materials capability. This particular client had SAP. And being able to take things that happen at the top of your bill of materials, like your finished goods, or not even finished goods, above finished goods, packaged finished goods, pallets of boxes of finished goods, all the way down to raw ingredients, raw packaging, so paper, ink for labels, glue, plastic wrap, or ingredients for the materials. So yeah, in this case, it was a FMCG, fast-moving consumer goods. So things which would end up going in a box of 24 bottles of something, right? Bottles of shampoo, bottles of mustard, whatever it might be. And so taking things which happen at the top of a bill of materials and attributing them down the way to ingredient, but then looking at cost models, which are generally at the bottom of the bill of materials. So you may have a cost model for a particular ingredient. So what's your cost model for the plastic wrapper, right? Well, what goes into it? You've got energy with the energy cost. How much energy goes into making 1 ton of plastic wrap? The materials, well, what goes in there? Is it ethylene? As a raw ingredient, you're going to have this manufacturing chain from crude oil, ethene, ethoxylation, ethylene, all the way to make, potentially low density polyethylene, high density polyethylene. So there's a cost model for that. Well, what if one component of that cost model, like say there's an oil crisis and the price of naphtha or ethylene doubles? Well, that's one part of one cost model for an array of ingredients, which then go into a bill of materials, propagate up the bill of materials to be attributed at finished good level, because it's the finished good level where you're going to see what it's going to do to your margins, because you don't record the margins at the ingredient level. So this was very graphy, an incredibly important business question. And yeah, the data inputs were, in this case, structured. So the opposite of the first use case. This was entirely structured data, no unstructured at all in this particular one, but from a huge variety of sources. So for the cost models, you might have external paid for reports, which come in Excel or come in JSON. Then you might have internal data sources for planning and manufacturing, SAP being a key one. The formats themselves could be different: tabular, normalized tables, second normal form, denormalized tables, JSON structures, CSV, fixed width text, all kinds of things. And in this particular instance, it was dual hyperscaler. So we had Azure and GCP, but we've had other clients who were Azure and AWS. And so extremely complex structured data environment, again, plus graph, was the enablement for the LLM interface. Any questions on the manufacturing?
There's one question. Harry asks, is this basically a text to cipher application? And he says, not that is basic.
Text to cipher was part of it. So natural language querying, I won't say what language it was. Let's just say it was cipher. It might as well have been. Most of the graph languages are either Gremlin-based or cipher-based. So certainly text to, let's just say text to graph. So natural language queries, like the key scenario question, to a structured graph language was a very, very important part of how this went. Because I think a lot of the graph industry, until good text to cipher or text to GQL or text to Gremlin or text to whatever, right, became possible, had to do this on pre-canned queries, right? You would have, say, 5, 10, 15, 20, 50, 100 predefined queries, and then you would get the LLM to basically pick the most likely one, right? Find one which kind of did what sounded like the question. So really the LLM was just being used almost like a text matching and likelihood. They probably are asking about something like this question, and then you'd go and execute that query, get the results back, turn the results back into something natural language English or other language, present it back to the user. But in this case, we did have some of those for particularly complex scenarios where the LLMs were not very good at writing them, but we also had a text to graph query language capability. So it incorporated both some element of pre-canned for the very, very complex questions, which would be worked out with the business users in advance, the kind of things they might want to ask on a regular basis that required extreme fine-tuning. But simpler things were just straight text to graph.
There was a follow-up that says, would that mean that the key challenge was the heterogeneous nature of the data?
Yeah, absolutely. So yeah, of these two sides, right? The right-hand side, the question, and the left-hand side, the huge variety of data. Yes, absolutely. The challenge was the huge variety of data.
And maybe just a question or a comment. A person asked if you can kind of, as we go through, and obviously there's a big slide with the architecture at the end, but if you want to kind of tease it out a bit, feel free to do so as you go through them.
Yeah, no problem. I mean, yeah, like I have no particular attachment to showing this last, but this kind of shows at a very, very high level. Like this is not an architecture diagram, and I'm not going to pretend it is. This is a very high level kind of view. I'll just call it a view of some of the things that can work together well in this kind of scenario. So yeah, at the risk of ruining the punchline, this is kind of the punchline. So across a huge variety of data formats and a huge variety of methods of originating data. So internal data, external data, things which may be already graph native, like Blue Yonder and SAP now have their own inbuilt ontologies. I don't think Palo Alto do yet. ServiceNow are either thinking about it or have done it recently. Oracle Financials, etc. So this huge variety of structured sources of a variety of formats ingested into a huge variety of different storage. So SAP HANA can now run on Databricks, for instance, natively, or it can be sitting on Oracle, or I think they can go Snowflake now. But yeah, the storage is just extraordinarily vast as well. So having a graph schema and a graph ontology with either a physicalized or purely logical graph, which can inform your agents, associated solutions, which then query the graph. So using this kind of flow, and we'll come back to this in more detail. But yeah, like if I hope this helps answer the question. Okay, anything else on this one?
No, we're good.
Good. So the third one, an online fashion retailer. Again, I can't give names, but yeah, $1 billion company. Yeah, huge online fashion retailer. They had a single source of highly structured data. So again, what you'll notice is no two data landscapes are ever the same. Like scenario one, vast corpus of unstructured, mixture of internal and external. Second one, vast corpus of structured from a vast variety of different sources. This one source, highly homogenized in terms of structure, but in this case, extremely high dimensional, right? I've put in just a few of the dimensions that the data covered. So inventory, you can imagine the number of dimensions in inventory, right? At SKU level, warehouse level, inventory level, etc. Customer, you have the items themselves, color, cut, theme, material, detailing, everything, right? Fabric. The website, huge source of information. Purchasing, the purchasing teams, huge sources of information. Marketing, vast sources. I mean, yeah, you could almost say that some fashion retailers really are just marketing companies that just happen to have, physical stuff that goes out the door at the end. Sales, many, many others. Again, dual hyperscaler, but by a single data lake. So they had a very interesting kind of architectural solution around that, but extraordinarily high dimensional data. And again, this is the kind of thing where if you try to just use SQL joins, you just run out of capability, right? By the time you're joining 5 tables, each with a billion rows, a billion by a billion by a billion by a billion by a billion, left in a join, it just gets computationally just unwieldy. They had tried using denormalization and columnar, and they'd made some gains, but really it wasn't until they moved to graph that they genuinely started to unlock these very interesting questions which cut through a large number of these dimensions. So for instance, key scenario, what items from our inventory? Well, already you've got the items, well, hundreds of thousands of different kinds of items. Inventory, hundreds of thousands of rows of inventory stock would work well together. So bring them together in a theme. Well, a theme brings together kind of marketing, sales, website, customer, blending new and sale items, sale, marketing, website, and what would be some good themes, and what should our buyers, moving on to purchasing, be targeting to fill out the themes. So straight away, we're looking at theme creation, which LLMs actually are incredibly good at when they don't hallucinate. So they, again, before we started using the graph solution, and they just went straight, take the LLM, point the LLM at the data, and they said, I'm going to give an example. I'm going to make one up, because if I give you the real example, it might kind of point at something. So let's say spring. They said, give us a really good theme for spring break. Young college kids going on spring break. Give us a good spring break theme. Came up with some amazing outfits, really nice, spring dress, perfect detailing, perfect coloring, looked great. Said that it was from their inventory, gave it an SKU ID. It absolutely didn't exist. The dress didn't exist, the detailing, that thing, that SKU ID, none of it. It made up everything, right? And I'm pretty sure everyone who's kind of worked with any of the large language models would have had similar experiences. Plugging it into the graph, giving it a defined schema, anchoring it in the actual data was massively powerful and just completely eliminated that. And yeah, we were able to make extraordinarily fast progress from not very good to extremely good by bringing graph plus AI together. This was I think because they had the single data lake, it really was just about unlocking the relationships between the dimensions, which graph is just superb at. So because of the way they had already set themselves up, they had a very good IT team, they had really good architecture, great infrastructure, they put a huge amount of work into kind of getting their data good. We were able to deliver at extraordinary pace. Marco, any questions on this one?
Yeah, there's two questions. So Veronique asks, thanks for the overview. I'm specifically interested in the ways graphs are used in the architecture. I've noted text-to-graph extraction. How are the ontologies used? Extracted or for constraining LLMs? Can you get into some details of physicalized logical graphs?
Yeah, happy to. So in all of these instances, the ontology, the schema was structured. So even if it had been discovered first, it would be reviewed, analyzed, a human being, potentially with help from a specific kind of LLM, help me make this, schema better, would design a defined schema. So sooner or later, in all of these instances, these ones that we've already gone through, the one I'm about to go through, they all had a defined schema. So there are some great tools out there for flexible schema. So you don't need to have that. A lot of the GraphRAG solutions will just automatically discover a schema, use that schema, and use it flexibly. But in these cases, we had a defined schema. That defined schema would then be used by the agents or by the LLMs to kind of act almost partly like a guide rail. So as a data definition, as a data structure, we would explicitly say whether it was in prompt or whether it was in a particular agent that was the schema agent to say, use this schema. We define the properties, we define the node types, we define the edge types, use it. And that was part of how we were able to get a lot of these benefits, was by saying, right, you can't make up properties which don't exist. These are the properties. They are defined. Right? You can't make up entity types. These are the entity types. You can't make up relationships. These are the relationships. I hope that answers the question.
Yeah, there's a thumbs up. So well done.
Great. Okay, and then the final one, blended. Right, of course, if we've got one that's structured and one that's unstructured, of course, we're going to get one that's blended. And this was a global bank, again, multi-billion-dollar organization, vast corpus of data, mixture of structured and unstructured. So in this case, it was customer 360, but not end customers, so not individuals. In this case, the customers were companies, right? It was commercial banking, part of the global bank, and they were looking at unstructured data that had been sitting in mostly PDFs, so terms and conditions, contracts, product descriptions, etc., but wanting to combine that with structured data from sales data, CRM massively, finance data, etc. They did not have a hyperscaler environment. That's a copy-paste error when I was making the slides. They were single hyperscaler, but it was also with internal storage, so it wasn't all cloud. It was a mixture of cloud and on-prem. Yeah. If I do this again, I'll change that bullet point. But yeah, the key scenario for them on the business side was something like, what would be the best commercial lending product recommendation for this client on the distribution side? Already, an interesting question. But as an addition, can we recommend any of our supply side clients? So for those of you who kind of know a little bit about some of the commercial banking, this could be, say, invoice financing. So let's say the initial client was somebody on the buy side. Let's say it was somebody in America who distributes water pumps, right? And they buy water pumps, ship them over, sell the water pumps. They were looking for a commercial lending product, but there might be people within the bank, clients within the bank, or people in the sales team who know about potential clients within the bank on the sales side, people who make water pumps, potentially in a different part of the global organization. And so there's this thing of, right, well, not only do we want to recommend the best product to the person who's buying them, but potentially we can say, oh, by the way, in terms of supplier robustness, are you aware of, XYZ pumps from, Turkey? Oh, I don't know them. They make pumps, do they? Yeah, well, they're a client of ours. So it was that kind of network effects at a commercial level from different parts of the organization, both geographically and potentially divisionally. And these were the kind of synergies that they were hoping that this product would unlock. What can we do? And so having the terms and conditions, you want to make sure it's a good product recommendation, but also the relationships and how can we bring those together. That was really the solution for them. And so, yeah, having the graph capability to support the agentic framework, and they were very much a multi-agent scenario. That wasn't singular chatbot. They really wanted MAS, multi-agent solutions for that one. And yeah, again, we were able to help, and we were starting to get some good results. This is the one which is not in production. So yeah, global banks move slowly. They get there, but they have to be super extra mega careful with absolutely everything. As a consultant, that kind of frustrates me, but as a banking customer, I appreciate it that they take their time. It's my money they're looking after, so it's kind of the way it is. But yeah, any questions?
Question is from Veronique as well. Can you let us know how many customers were covered in this use case?
Nope. I absolutely cannot. Apologies. I'm just going to say many. Some number between a big number and a very big number.
Cool. That was the only question so far. But if there's any others, feel free to keep them coming.
Good stuff. Thanks, Marco. Okay, so yeah, if we look then at this sort of high level how things fit together, I think people are pretty familiar with the left-hand side, right? People kind of know how data architecture works. People are starting to get much more familiar across the community about the right-hand side. So the large language models, agentic frameworks. I could only find a couple of logos, so I know that you've got Claude agents, and there's other things down here in the agentic frameworks. But N8N gets used a lot, particularly in banking and some of the more structured organizations, because they want this sort of deterministic agent-to-agent automation within N8N, and they can kind of coordinate the models, plug into whichever they need. But yeah, really the key point, and I think this follows up on what Veronique was saying, is how do you manage the ontology? How do you manage the schema? What does it do, right? And the reason that this word here, I've chosen or, physicalized or logical, is because you don't need necessarily a graph database or a physicalized graph in memory solution for this to work. You can just have a graph logical model sitting on top of tables. And I think, from a Memgraph point of view, you guys have really started to look at this and embrace this with Mem0. There are other solutions out there. We can see that, Google's moved into this space with BigQuery Graph, where you leave your data in BigQuery, but you can have a logical graph model and then query your tabular data in BigQuery as if it was a graph, and they're getting amazing results. So, obviously I'm here with Memgraph, but it's kind of the way people are going is you can physicalize the graph if you want to, or you can potentially just have a logical graph model sitting on top of relational tables. The key thing is the schema and the ontology. So giving this to the LLMs just makes their ability to query interesting, high-dimensional, high-dependency, complex data scenarios just so much more powerful. If you try and do it without the ontology, they burn tokens, they have to have massively expanded context, they hallucinate, they become inefficient, they take a long time to run. This is really the key part of this kind of architecture. And so, way back slide 0, we said unique domains, common solutions. This is really the common part of the solution is use an ontology, use a schema design, use it to inform your LLMs, your agents, your multi-agent solutions to make your querying cheaper, faster, more efficient, more predictable, lower hallucinations. It really is like an LLM superpower, adding in a structured ontology. Just spend half a day on LinkedIn and you'll see 10,000 ads for context graphs and context solutions and ontology solutions, etc. Like how you do this and with what solution you do this, well, take your pick. There's hundreds of companies. Obviously, Memgraph's one of them, and Memgraph does a very good job in this space. We're going to hand over to Marco. He's going to give us an example. But really, this is the key pattern. This is the key part of the architecture. Have a schema, have an ontology, give it to your LLMs, use that to make the queries better. Okay, any questions before we hand over to Marco?
There's one question, more of a definition question. What are actually the logical graphs?
A logical graph, it's where you don't change your data. You don't do anything to it if it's already in a table, for instance. So if you have something like a large denormalized table, or you have some tables in second normal form, so you've got maybe foreign keys, primary keys, etc., or you just have some tables, or you just have some unstructured data that you can address. You can still build a logical model, for instance, like the Chen ER model, or you could build a second normal form model without actually touching it, or you could build a graph model of that data without necessarily having a graph database, which would require you to physicalize the nodes and the edges. So you can leave your data in tables, not move them into a graph database, which would be physicalizing them. So you would write node table, you would write node into memory, you would write edges into memory, you would write them into storage. That would be physicalizing it, right? So you don't physicalize the nodes or the edges as nodes and edges in a graph representation, in a graph solution necessarily. So an example would be of a logical would be BigQuery graph, or potentially Mem0 as well, right? Where you come up with your ontology, you design it on a blackboard or a whiteboard or a piece of paper or Lucidchart or draw.io. It's logical, it's not physicalized in any way. You then turn that into whatever the solution requires. So BigQuery, to use BigQuery graph, you need to tell BigQuery graph what the objects are and what columns and what rows represent nodes, what represent edges, what represent properties. So you need to tell it what the data objects are and where they can be found so that they can be queried as a graph, but you're not changing any of that data. You then run your, in the case of BigQuery Graph, GQL, or in the case of Mem0 Cipher query, it will then execute that query as a query plan on that underlying data, but without doing any kind of ETL, no transformation. You're not taking a copy of the data and writing it in graph memory or graph storage in any way. So that's when it's logical rather than physicalized.
Cool. There's additional two questions. So how do you pass the graph extraction to the LLM? What is the format that is used?
Oh, irrelevant. Anything you like. You can pass it in JSON, you can pass it in YAML, you can pass it in raw text. This honestly doesn't matter because ultimately what these things are is gigantic chi-squared pattern matching engines. They don't care. They don't care what format this comes in. You could probably just about give it this image and tell it to read the image and interpret it, and it might do an okay job. I wouldn't recommend that. Take that one off the table. But personally, we tend to use YAML. We find YAML is a really nice blend of human and machine readable. So machines can read it because it's structured. Humans can read it because it's nice and easy to read. It doesn't have all the curly brackets and quotes and stuff that JSON tends to have. It's JSON interoperable. So yeah, as a recommendation at Pinboard, we tend to recommend to people to use YAML, but you don't need to. You can just do it in plain text if you want to. You can just say there is a node called BOM, there is a node called plant, there is a relationship called has BOM between BOM and plant. Like it doesn't matter. The LLMs are so smart. They're so capable at doing the text distance matching. They'll work it out.
Cool. And one more question. Can you talk a little bit about the ingestion? So how is the ingestion done? What are the frameworks, libraries that you used, and what models, if you kind of used LLMs kind of for extraction from unstructured data, what did you use?
They're kind of all good. Apologies, that's not a particularly good or helpful answer. But as a consultancy, we tend to use whatever the client has. Like you walk into a site and they've got that kind of screwdriver, you pick up that kind of screwdriver. They've got that kind of saw, you pick up that kind of saw, right? So if they're a ChatGPT house, we use ChatGPT. If they like LightRag, we use LightRag. If they like BAML or BERT, we use BAML or BERT, right? If they have complete greenfield and absolutely no idea, then we'll just kind of take a look at their infrastructure and think what might be a good fit for them. But in our experience, none of them are particularly better or worse than others. Like the choice of that solution is not going to make anything like as much of a difference as the choice to use Graph or not. Right? It's like a third order thing, right? First order is use a graph. Second order is do we physicalize it or logicalize it, or what kind of solutions do we have? What do we need to do? Those sorts of what do you use to form the structured or unstructured? There's so much choice. There's not much to choose between the different choices. So yeah, we tend to just go client by client, ad hoc, and by next week, something might be better than something else. And then in 2 weeks' time, something else might have overtaken something else. There's a new thing from Claude, or there's a new thing. It's such a changeable landscape. That particular part of the architecture, strides are being made literally daily in some cases.
Maybe a final question, and this one's from me. Would you be able to tell us a little bit about kind of how do kind of, I guess, these customers, but I guess in general, people that are building, that are using kind of these systems, how do they see the value on the other side? How do they grade it? How do they mark it kind of as a success? If you know, like there's a plethora of different, obviously, kind of domains kind of here. There's obviously kind of different kind of use cases, but what would be kind of the success kind of in those projects that they would kind of that they would be aiming for?
Yeah, I mean, most of them don't have a well-defined ROI. Right? So an instance where we did have a very, very good, well-defined ROI as a baseline minimum was around an entity resolution. They were using entity resolution to attribute different properties to a single customer. So they might have a good customer address in one system, they might have a good customer email in another system, they might have a good customer mobile phone number in another system, but because the systems were quite isolated, they wanted to do entity resolution. In that instance, it was very much marketing driven. So marketing were like, well, we know we want to contact these customers. We want to contact these customers via email. We don't have an email. We only have an address. In that system, there's no address. We have a name, but the name's ambiguous. So how can we do this kind of entity resolution? So in that case, we were quite lucky. We did have a very well defined. It was, if we can contact this extra percentage of customers per our marketing cost models and cost benefit models, we can deliver X gains. That's very unusual. For these ones, most of what the clients tend to be looking for is better. Very hard to put a number on. They were able to get the budget. I think reading between the lines for quite a few of these, what they were also looking for is don't fall behind. I think the fear of falling behind is huge in a lot of these organizations. They know their competitors are making huge strides. They know they're making huge strides, which they want to keep quiet. They know that if they don't do these things, they will be beaten by people who do these things. And that kind of number, it almost acts like, it's almost like a lever. It's not a number. It's just, we will do this. Do it. What's the ROI? Well, if we don't, we're going to die. Not literally, but we're going to die as a company. We're going to get outcompeted. We're going to get, productivity is not good. All those amazing reasons. And I think in a lot of cases as well, it was about learning, right? Trying to find an architectural pattern that works. So if they're the team that goes, look what we managed to achieve, then the ability for that to then propagate within the company and make everybody more effective. Again, this is something that they were all kind of looking for. Everyone's trying 10 things and they find 2 that work. Right, stop the 8, continue the 2, roll those 2 out across the board. And I think this is being used, partly in experimentation. But as I said, most of these are now in production. People have realized that this is one of the, 2 out of the 10 approaches that really works and really scales and really makes a difference. And they're starting to roll them out. This is what we're seeing for the rest of 2026 into 2027 is going to be, okay, we've now got something like a repeatable pattern that we can start rolling out. Roll it out to this team, roll it out to that challenge, roll it out to that product, productivity crisis, roll it out to that XYZ. That's kind of the mode that we're starting to move into, I feel.
Amazing. Cool.
Okay, I'll stop sharing.
Cool. Great. Well, thank you so much for the presentation. I'll back to gallery before we sign off. So as Max was saying, he gave us 4 very cool, basically examples of the architectures. But what I wanted to showcase in the last 10 minutes of the presentation is we have created a demo where we want to walk everyone through basically the questions and how to get the better answers with the questions. And we definitely wanted to showcase what are the massive kind of or big challenges that kind of people are facing with the questions that they usually kind of pose. So I'll go into the full screen. So the problem, as Max as well kind of mentioned, is enterprise documentation is structured and that knowledge is trapped in unstructured storage. So data basically lives across various versions, and usually kind of the old docs persist. There's dependency challenges, and then various same terms can mean different things in different contexts. And every organization, kind of big and small, and the bigger it is, the more of it has basically various documentation and various documents with these patterns. And now with LLMs, the main question pretty much becomes, can actually your AI system answer the questions that you actually need rather than just search for similar text? So what we did in terms of showcasing this, we have created basically an example of a data set that is based on a completely made up Nexus platform, which is basically an enterprise data integration product that comes with its own documentation from security, ETLs, scheduler, connector frameworks, REST API, dashboards. It has kind of Snowflake connectors, Kafka, JDBC, S3, and various other ones. And we have created kind of the documentation corpus, which has architecture docs, configuration references, migration guides, all the good things that you would see in enterprise data integration product that has multiple versions, how to upgrade, how to go from one to the others, what are the limitations, what are the good things that you can do, how to basically get out of the problems that you get yourself in. Now, all of a sudden, with LLMs, you don't actually want to go through basically the documentation. You want to ask questions directly on it. So in order for us to really do that, we've come up with 5 types of questions, and these are well known, so I'm not going to spend too much time on it. The question categories are completeness, basically what it tests. It tests kind of a complete, exhaustive kind of list of things. A dependency category, which basically tests facts across multiple documents and multiple points in time. Causal questions, so if I change X, what breaks? If something changes, what is the impact kind of that? Contradiction questions, where corpus contains different correct answers for various different versions. And then finally, the disambiguation questions, which basically uses ambiguous or legacy terminology that's outdated and basically brings it up. So we've taken kind of this corpus of 82 documents. You can kind of see a glimpse of it on the left-hand side. We've created a schema from it, basically extracted the entities, created relationships, and created a graph so that we can actually ask the questions and showcase those examples where asking the question with graph definitely makes sense. So this is the demo. I'll kind of stop kind of the screen sharing and I'll jump into the other basically window. So we've got kind of the demo, and there are a number of kind of preset questions, and this is a live demo. You can see as well on the top. It's kind of hosted kind of locally as well. So first live demo. Hopefully live demos still work. But basically, what we want to showcase is we want to show kind of completeness and kind of get the answers kind of on the completeness. And multi-hop and causal. We're not going to go into disambiguation and contradiction at this point. But once we click each of these kind of questions, we'll see what we get kind of with VectorRAG and what we get with GraphRAG on the right-hand side. The really good thing as well is that through GraphRAG and basically by creating it with graphs, the capabilities, the chatbots, you get a sense and you get the ability to actually trace back kind of that answer. So you can actually then see what was being traversed, what was being queried, to actually see, okay, well, this is how the LLM actually replied to my question. So let's dive into the examples. We're not going to go. We have only 3 questions, so no worries. Give me a complete inventory of everything that depends on the auth module. So as an example of a complete question, we click ask, streaming, so live demo hopefully comes. Okay, it comes and it's coming. So basically what we're trying to get with this kind of completeness question is we want to basically showcase and see what are all the things that depend on the auth model, which is basically the definition of the completeness. So give me all the examples, give me everything that is connected kind of to it, where the massive risk is if you basically get a partial answer, or if you don't get, or if you flip it on the other side, if you don't get a fully complete answer. And you can see what we got. So there's obviously kind of dependencies. You can see kind of the access behavior. You can see configuration requirements. There's definitely things that VectorRAG kind of picked up on the left-hand side, but I'd probably argue it's not kind of complete enough. What it also obviously kind of shows us from the traceability perspective of, we can actually then go and check it out. We can actually see what are the entities that were actually involved and what are the relationships of how the alt model is actually then connected to other entities. And you can see there's obviously a lot of relationships that were connected, that were basically passed in order to surface the right connections. Now, again, this is obviously done on a very imaginary kind of company documentation, but in a very real scenario, if we take an example of a pharma company, and now all of a sudden, they are asking, list every clinical trial where a particular drug X has been used. Well, if they are really, if they don't check, if they don't go back, then they might miss something. They might not get a fully complete answer, and obviously that is super important. So we're going to go to the next question type, which is the dependency question type, or the multi-hop. So the example that we're going to showcase is obviously various versions and various products in their documentation have upgrading paths and basically migration. How do you upgrade from one version to another? And if you skip a few, then kind of you basically need to know how to really do that. The main point of the multi-hop or dependency type of questions is that you need to go through multiple documents, because you basically have, how you set up one version, you have how to set up a different version, how to set up a third version, and those are three documents that live in a fully independent kind of a way, and not a single document contains basically the full chain. So the risk that we basically encounter here is that you basically might get only, again, a part of the answer. You might get the best answer from kind of one chunk, best answer from one version, but then it kind of a little bit kind of hallucinates and doesn't get the full truth on the other side. So, for example, I can give a finance example, and I'm quite sure Max had kind of a few of those. So if you're asking questions, again, about kind of across kind of multiple documents that are kind of linked and you're assessing risk, you really need to make sure that those documents that you are traversing actually give a full picture, rather than just being taken kind of from, 90% is not going to cut it if you're really looking for very detailed and very precise kind of answer. Basically, you will pass it and the dependency will be missed. And then the third type of question is kind of a causal answer, a causal question. So if this, then that, and I'll take the example of what happens if we disable the auth module's token caching feature, kind of what breaks. And the main point here is what we need to do is we need to basically pass through kind of and follow the dependency from basically that change to everything else that change and kind of touches, and all the downstream effects kind of it. Even though they might not be fully related to that change, these still things kind of happen downstream. So we can kind of see, obviously kind of there's kind of answers that kind of gave here. One of the things that we obviously kind of that I knew that would happen would, increase the likelihood of an error events, whereas those kind of things are not visible kind of here. So again, when you're working with and need precision, and you want to kind of observe downstream effects, and basically you get kind of the full picture, you want to kind of do it in this way to basically help to basically get help from the graphs and their inherent connections and relationship that it has. So, for example, I can give an example in HR. So we can talk about employees and contractors being kind of reclassified. So that answer is not only, oh, it's going to have an impact on the budget, right? Like it's going to have an impact on PAYE. It can have an impact on the benefits. It might have an impact on the headcount reporting. It might have an impact on various approval workflows, on procurement contracts with staff and agencies. Like a bunch of things can be impacted by that. And you then, as a decision maker, as a user of that, you definitely want to make sure that you have kind of the full view of that and get the proper answer. So that was a little bit of a demo kind of question and answer that we wanted to showcase. I'll go back to the slides. There's 2-3 slides left. Basically, what we wanted to showcase was that you're getting way better answers with graphs. And obviously, there's a number of categories of questions, but basically every category gives a more complete answer. So on the completeness side, you get a full dependency tree. Every connected element is found, so not just the ones that are similar or appear in nearby texts. On the dependency side, it allows you to basically go through the document chain. So the graph obviously would follow references and surface relationships that span basically the entire corpus. Causality, we talked about that. If this kind of then that, you basically want to make sure that you get all the touch points of the downstream effects of kind of certain changes and impact. Contradiction and disambiguation, we didn't give a demo, but basically contradiction means that the graph knows which version each fact kind of belongs to and returns the full answer for the right context, whereas the disambiguation resolves entities. So if there are same terms that you have, which you can usually kind of have, but they might have different meanings, the graph resolves that due to the relationships rather than just the fact that they are kind of same. Final slide, clear business outcomes, and I'm really happy for the question that I asked Max. So basically, what we have seen, and I'm sure he would agree, the business outcomes on the user side are bigger speed, higher accuracy, more visibility than before, so surfacing things that are previously were invisible, and then simply democratization. I sometimes say it's kind of cutting out a little bit of the middleman, but basically now every non-technical user within the organization, if the system is basically built in the right way, they can ask complex questions kind of directly, which then again goes back to the speed, goes back to the accuracy and increased kind of productivity. So overall, it's kind of increased productivity, but then with graphs as well, there's a thing that says traceability is included, which gives a whole lot of sense for all the high risk and regulated industries that actually really need to check. They can't just act on the probability kind of aspect of and nature of the LLMs, which obviously are and work in the probabilistic sense. They do need to actually go and check how were things kind of connected and where did they actually kind of get an answer. So graphs obviously kind of provide that. So that's pretty much it. And before I sign off, I definitely want to thank Max for the great presentation. I think it's been really, really good to kind of see the architectures and to dive into I'm going to pull Max on stage, and to basically dive into the details of each of the use cases. Obviously, kind of they're structured and unstructured, and then sometimes they blend, and every kind of company has their own kind of tool in the box that they use. But that's also the opportunity for everyone to basically get kind of those answers out. So anyway, if you want to see the demo or if you have any questions, feel free to reach out to me or reach out on Discord or any other way. We'll share kind of obviously as always kind of the presentations and the recordings, and we'll definitely share Max's details if you want to dive in. I'm sure he will be happy to geek out about all things graph.
Yep, 100%. Thanks, Marco.
Amazing. On the spot, time's up. Thank you so much. Have a good one. Bye bye.
Cheers, everybody.